Good afternoon. We are made of Reina, Fatima, Edgar, Jimena, and a servant. We will be explaining to you about the topic of the inverse of a matrix. An array is a rectangular array of numbers, symbols of expression, organized rows and columns. Matrices are key to linear algebra due to their ability to represent and solve complex problems efficiently.
What is the inverse of a matrix? The concept of inverse of a matrix is a multidimensional generalization of the concept of reciprocal of a number. The product between a number and its reciprocal is equal to 1. The product between a square matrix and its inverse is equal to the identity matrix. The inverse of a matrix is the matrix that on multiplying with the original matrix results in an identity matrix. For any square matrix A, its inverse is denoted as A1. The inverse of a matrix is obtained by dividing the adjoint of the given matrix by the determinant of the given matrix.
Condition for existence. The rank of A must match the smallest of its dimensions, number of rows or columns. This means that its rows or columns must be linearly independent. Square matrix. The square matrix A is matrix B that satisfies the relation A of B determinant distance from zero. The non-zero determinant of a matrix refers to the necessary condition for a square matrix to have an inverse. If the determinant of matrix A is non-zero, then there exists an inverse matrix A of A1. A non-zero determinant indicates that the rows or columns of the matrix are linearly independent, which allows an inverse to be calculated. Rank equal to order. The rank equal to order of a matrix is condition that guarantees the existence of an inverse matrix. For a square matrix A of order n, the rank must be equal to n, which means that all its rows or columns are linearly independent.
Inverse calculation. To calculate the inverse of a square matrix A using the matrix multiplication method, follow these steps. A square matrix A is invertible if its determinant is not zero. Calculate the determinant of I that A if the A is not zero, then A is invertible. Second step. Form an argument matrix placing of the left and the identity matrix is of same dimension as A on the right. Third step. Apply elementary row operation, row swapping, row scaling, or adding a multiple of the row and node to turn the A portion of the argument matrix in the identity matrix. Simulation apply the operation to the right side, the identity matrix. The operation on the left side will turn into the identity. At the same time, the right side argument matrix will become the inversion of A. Fourth step. Side of argument matrix has become the identity. The right side will be of inversion of A. In other words, if A B is the resultant, then A could equal B. Fifth step. Its original matrix inverse is calculated as A minus 1 equals 1 determinant A asterisk adjoint A.
Now we will do a small example to understand better. We will check if the pairs of matrices are invertible. We have the matrices A and B to check if they are inverses or not. Let's calculate if AB equals BA using the matrix multiplication method. First, we will multiply AB placing the matrices in that order. Matrix multiplications are done by multiplying row by column. Remember that this is the row and there is the column. Having said that, we will multiply the first row by the 3 columns and it will look like this. We will do the same procedure for row 2 and finally for row 3, thus obtaining a new matrix for AB. Now we will do the multiplication of BA. We will use the same row by column procedure. Taking out the first row, second row, and for the last third row. Get a new array for BA. After performing the multiplication, we can realize that AB equals BA since they obtain the same results. This means that A and B have an inverse, where A is the inverse of B and vice versa. And this is how we obtain the inverse of a matrix by the matrix multiplication method.